Okay, so this video is on the remaining trig inverses. So these are our reciprocal ones. Cosecant has this domain restriction. It looks kind of scary, but it's really not that bad. So it goes from negative pi over 2 to pi over 2, but it breaks at 0. So it has straight brackets at the end, which means those are included. So this is what that would look like. Make sure that. So negative pi over 2 to pi over 2 with a break at 0. So it's still mainly quadrants 1 and 4. And then inverse secant goes from 0 to pi with a break at pi over 2. So 0 to pi with a break here. And then cotangent goes from 0 to pi, not included at the ends. So I want you to draw this real quick picture. It's just generalized. It doesn't have the breaks in it. But it basically shows you the quadrants for the function. So cosecant, secant, and cotangent have domain restrictions for quadrants 1 and 2. Tangent, sine, cosecant have domain restrictions for quadrants 1 and 4. Now we're going to use that down here. So what's happening down here is we have our reciprocal trig functions. Remember that secant is the reciprocal of cosine, so 1 over cosine. Cosecant is 1 over sine. Cotangent is 1 over tangent. And so when we did sine, cosine, tangent in the previous video, we could just read those values right off of our unit circle. However, our unit circle doesn't have values for secant, cosecant, and cotangent, but we can use this property of being reciprocals of each other to convert them to sine, cosine, or tangent, and then we can use our unit circle. And so here's how we're going to do that. We're going to rewrite inverse cosecant of 2 by taking the reciprocal of everything. So cosecant is really the reciprocal of sine, so we're going to do inverse sine, and we're going to take the reciprocal of 2. Well, currently 2 is over 1, and its reciprocal is 1 over 2. So now we have a sine function that we can use our unit circle for. Which angle or angles has a sine value of 1/2, or in other words, a y coordinate? Now, real quickly before I answer that for you, I have this question. We started with cosecant, we went to sine. Which one will we be looking at the domain restriction for? And the answer is whatever the original problem said. Now, it just so happens that cosecant and sine have the same quadrants for their domain restriction, but that's not true in all cases, which we'll talk about in a minute. So when you're trying to figure out your domain restriction, you're going to look at the original problem, even though you did rewrite it in its reciprocal form as sine here. So take a moment, find your unit circle. Where is the y coordinate equal to 1/2, and where is it also in our domain restriction? So hopefully you found pi over 6. In number 2, we have inverse cotangent of this value. So we're going to take the reciprocal of both things. So this becomes inverse tangent, and this becomes -3 over rad 3. Now, nowhere on our unit circle do we have values written as 3 over rad 3. So we're going to rationalize this denominator. All right, so now I've got negative rad 3. So now the question is, which angle has a tangent value of negative rad 3? Which angle or angles has a tangent value of negative rad 3? So I want you to pause the video and find that on your unit circle. All right, so you should have found two places where tangent is negative rad 3. Here, down here is one, and down here is the other one. So the question is, which of them are in our domain restriction? Because in this case, there's two different restrictions we're talking about. Tangent is in these two, the tangent domain restriction is here in these two quadrants, which would mean choosing this answer. However, cotangent domain restriction is these two quadrants, which would mean choosing this answer. So how do we know which one we need? Well, we look at the original problem. The original problem was cotangent. So this is the domain restriction that we're going to default to. So cotangent is the first and second quadrants, which means our tangent negative rad 3 angle that we're going to be looking at is, or we're going to be answering, is 2 pi over 3. And I want you to take a minute using these reciprocal functions and the things we've already talked about and finish out the rest of these problems. Pause your video and try them yourself. Okay, here's my work for the rest of those problems that you just tried, 3, 4, 5, 6. Pause the video so you can check yourself, and we're done.